In this video, we will be covering how lift is generated and how the angle of attack, airspeed and air density affect lift. Let's start with how lift is generated. The top surface of an aircraft's wing is more curved than the bottom surface. This means that the air flowing above the wing must flow faster over the top surface in order to meet the air flowing underneath the wing at the same time. The air flowing over the top is essentially being forced through a constriction between the top surface of the wing and the undisturbed air. The increased speed of the air flowing above the wing causes a drop in pressure above the wing compared to the rest of the air. As a result, this difference in pressure generates an upward force which is known as lift. The more curved the surface is, the more the speed increases at that point, and therefore the more the pressure drops and the more lift is generated. Now that you know how lift is generated, let's move on to the angle of attack. In most flight conditions, the wings meet oncoming air at a slight angle. This is known as the angle of attack and is labelled as theta on the diagram. This is the angle between the chord line of the wing and the oncoming air. This angle causes some of the air to be deflected downwards as it flows over the surface of the wing. This deflection of air results in an upward force which creates more lift. The larger the angle of attack, the greater the effect. However, if the angle of attack goes beyond the critical angle for the aircraft, typically 15 degrees, the smooth air flowing over the surface of the wing breaks away, becoming turbulent, and all lift is lost, causing the aircraft to stall and potentially fall out of the sky. The pilot can control the angle of attack by pitching the aircraft upwards and downwards. Now let's see how airspeed affects lift. Altering the airspeed will vary the amount of lift produced by the wings. When an aircraft is stationary before takeoff, the wings are producing no lift. However, as the aircraft accelerates along the runway, the lift increases until there is enough to counter the weight of the aircraft and lift it off the ground. This is because the faster the airplane is moving, the more air particles are flowing over the surface of the wing in a given time, and therefore more lift is generated. Finally, let's look at how the density of air affects lift. As the air becomes less dense, for example with increases of height, temperature or humidity, there are less air particles flowing over the wings in a given time. Therefore, the amount of lift generated is reduced. Now for some questions to test your knowledge. Question 1. Does the pressure above the surface of the wing increase or decrease due to the increased speed of the air flowing over it? The answer is, the pressure above the top surface of the wing decreases. And question number 2. What is the critical angle? And the answer is, the critical angle is typically 15 degrees. It is the angle of attack at which lift is no longer generated and the aircraft stalls.